what we'll be doing. Okay. So before we get into, let me give you overview of everything we're doing for this chapter. Someone already asked me, how is this chapter compared to the last chapter, the logs? It's a little bit more difficult. The last chapter and this chapter are generally considered the two most difficult of the whole year. Right, so just be prepared for that. You'll notice if you're absent 1 or 2 days, how much that changed your understanding of everything and how difficult it was to catch up. So if you're absent, especially for a school reason, like you're just in choir or something, do not show up next day saying, "Oh, I don't get any of this." Like, you need to make sure you get it. Otherwise, don't miss class. So if you know you're going to struggle, don't miss class. Don't do that extra little thing. Don't do anything that takes you out of math. Or you can also just watch the video that's posted, and that will help a lot, but maybe not everything. Okay? But don't presume that if you just miss a few days, it'll be simple to catch up. It's going to be a much longer chapter. Okay? So a couple things we'll need to know is where are we going. Okay, so chapter 10 is called the conic sections. Okay, sections. Conic sections. Okay. And it's really made up, the word conic comes from this shape right here. Okay, it's like a cone, tip to tip. And we start looking at these cross sections. So if you can imagine taking these cross sections, these blue cross sections, and looking at the shape that it actually makes. Okay. One of them we've already looked at extensively in Algebra 1 and in Algebra 2. Okay. That's the basic parabola. Okay. Basic parabola. So if you can imagine taking a flat sheet into a side of a cone, the shape that is made is just a parabola. Okay. We're going to be finding learning a lot more about a parabola than you've ever known before. Okay. We're also going to say, well, if you take that cross section straight, exactly straight in, not at an angle at all, okay, that's a circle. Okay. Just imagine chopping off at a 90-degree angle the top of a cone, you see the shape of a circle. So we'll look at what's the equation of a circle. How do you graph a circle? Okay. So you're going to see that it looks like, let's see here. So first of all, the parabola was, I think, in this format. You might recall. This is a parabola. Called vertex format. A circle, the equation of a circle looks like this. X squared plus y squared equals r squared. R is the radius of the circle. So each of these is going to be like its own section, its own part of the chapter. We'll spend a few days on parabolas, a few days on circles. Okay. What if we go at a slight angle? Okay. So it's not the same radius all the way around. It looks like an ellipse. Okay. That shape. Okay. It's like an egg shape. Okay. Or a orbit of a planet is ellipsoid. It goes in an elliptical shape. It doesn't go in an exact circle. Okay. So what are the equations of that? Okay. And then what if you take this vertical cross section where you have really two parts to the graph. It crosses at the top and it crosses at the bottom. Okay. Called hyperbola. And graphing those. So this shape kind of looks like two parabolas. One's opening up, one opening down. While it's not a parabola shape, it resembles it somewhat because it has some different properties. But the graph includes a top part, a bottom part. It can also be a left part and a right part. They can open up the sideways as well. And we'll look at the equations of those as well. So like before, with a parabola, we can move it up and down, left and right, make it skinnier, make it wider. We're going to be looking at all those for circles. Like how do you change the center of a circle? How do you change how big the circle is? Same thing with ellipse. How can you make an ellipse very skinny? How can you make it almost circular? What do you change with the equation? Similar to here, how do you change the equation to move it up and down, left and right? So it's all about moving and translating these shapes around and knowing how they operate. Okay, so that's where we're going. Okay. A lot of what we're doing is based on the parabola. So if we can recall a lot of this stuff, mainly this vertex form, if we know how to get in this vertex form, it makes a lot of things a lot easier. So it's one of those, if you work really hard and you know how to do vertex form really well, it doesn't matter if it's fractions, decimals, large numbers. If any of that, none of that doesn't matter to you, and you can always do it, no matter what, you're in really good shape. Okay. So, but before that, we're going to get into basics, just like, Pythagorean theorem. Okay. And the main reason we're going to look at this is because all these require us to find distances. We need to know, well, how far is it from this parabola to a point called the focus? How far is it from this parabola to a point called, or a line called the directrix? There's a lot of new terms you have not heard before, so we're going to be talking about. We need to know, well, how far is it to get there? How far away they are. So how do you find how far it is from 2 points? Okay. Basically, you use Pythagorean theorem. You might also know it as the distance formula. Find the distance formula. Okay. Revisit this from geometry. So how far is it from this point, this point? If I give you 2 coordinates, can you tell me how far apart they are from each other? Okay. And basically, it was like a Pythagorean theorem formula, is what it was. Okay. If I can find out how far this leg is and how far this leg is, I can find out the distance, c. Although with the distance formula, instead of c, we use d for distance. If I just know how long this is, how long this is, I could do a squared plus b squared and take the square root, get my answer. That's really what we're going to be focusing on, is finding the distance. And it's going to be very familiar, that you've done it before. Okay? Find the difference between 2 points. This is like Geometry Chapter 1. Okay. Okay. And shouldn't matter if there's fractions or anything. We're also going to be finding the midpoint. So 2 formulas, we're just going to be practicing finding the distance, finding the midpoint. If we throw like a word problem at you, we're not going to, it's not going to make it harder or easier. Just know if you're trying to find the distance or a midpoint. Okay? And that's about it. Okay, so let's do some practice. Let's see here. Okay, so say I want to find the distance between these 2. And what are the coordinates? So it's 1, 2, and let's say 4, 7. Okay. If I want to know how far apart those are, okay, what we're really doing is saying, I just need to know how far this distance is. How far is it from 1 to 4? Okay. Right here. How far is it from 1 to 4? Say it's 3. How far is it from 2 to 7? Say that's 5. Okay. And to find the distance, we use that Pythagorean theorem. We said, 3 squared plus 5 squared equals c squared. We're going to use d for distance instead of c. Okay, that's just 9 plus 25 equals d squared, which is what, 34? So the square root of 34 equals d, which is about how far? 5.8. 5.8. about 5.8. To read the directions on any given problem, it might say, if it says find the distance, they want this answer. If it tells you give a decimal, then that's when you do decimal. So don't give the decimal unless it tells you. We want the exact otherwise. So, and that will affect whether you use an equal sign or a proximal sign. Okay. So the background is, how can I get this number in general? So from using these two numbers, 7 and 2, how can I get 5? That's just 7 minus 2. Okay. How can I get 3 using 4 and 1? Just 4 minus 1. So you might remember this formula of x2 minus x1 and y2 minus y1. That's where it comes from. Here's y2, here's y1. How do I get 5? That's 7 minus 2. y2 minus y1. That way. So we can just go straight to our formula that we want to use over and over and over for distance. It's just going to be this. Exactly. x2 minus x1 squared plus y2 minus y1 squared. And just put your numbers in and crank away. Don't make any mistakes on negatives. If you switch the numbers, would it come out to be the same? So if I did x1 minus x2 and y1 minus y2, you'll get the same answer. So, big picture here. The distance from here to here is the same as the distance from here to here. So it doesn't matter which one I call 1 and which one I call 2. It's the same line, so it's going to be the same answer. Let's just practice. Yeah, plug it in and see how it goes. Yeah, if it seems overly simple, that's because it is. There's nothing tricky about it. You just have to pay attention to details, and you're okay. Now, I warn you, this will be like the first step of a much bigger problem in the coming weeks. You'll take this number, you plug it into a much bigger problem, and you'll do 5 more minutes of work. So if you mess up on this one thing, yeah, everything after that's going to be the big mess. So while I say it's simple, it doesn't mean it's not important. Okay, and you have to be precise. Do not take shortcuts and try to do everything in your head and say, oh, the distance is just this. You'll find that will cost you dearly. So we're going to be careful at the same time. So we have what? 1 or 4. So is that right? 4 plus 3? And then what? Negative 4 minus 6. So what? 7 squared plus 10 squared. So that's the square root of 149. And you get the same thing. That's approximately 12.2. We had a good approximation. Okay. My hope is that by now you're not addicted to your calculator. You don't have to look in the calculator, type in square root of 149 to know that's 12.2. Square root of 144 is 12. 149 is just a little bit higher. 12.2 approximately. Okay. This number sense will help you a lot. If you're just addicted to that calculator to punch everything in there, it ends up slowing you down so much. Also, you just don't catch things that are obviously wrong later on. So if you get an answer like on the logarithms that was negative, if you're so used to just punching your calculator, you miss the obvious signs that, oh, there's no solution, because you're just typing things in. So keep that number sense alive. Try to resist typing every little thing in there. Okay, try to estimate the best of your ability. Okay. You might notice that I dropped the negative here. Negative 4 minus 6 is negative 10. But if I know I'm going to square it, I really don't care about the negative so much. So just one more thing to get out of the way so I don't have to worry about it. Okay, do we need to do another, or just, I think that's okay, right? Just make sure you know the formula. Okay, make sure you know that formula. That's the key. If we know it comes from the Pythagorean theorem, you'll never get it wrong. If you try to just flat out memorize it, yeah, it's kind of difficult. So remember, this is coming from here. A squared plus B squared equals C squared. B. And that's where it's coming from. Just the distance between that one leg you have to subtract to get that one distance. The second leg you have to subtract. And then we end up taking the square root of both sides. That's how we got D equals. That's why it's a square root. It's just the Pythagorean theorem. Alright. Is there anything? I think that's about it. Next. Midpoint. Finding the middle. So, likewise, if I gave you 2 points, can you find the exact middle of those points? This will be a segment. Have one. The exact middle. I can kind of estimate it, but they're not always going to be some nice numbers. So I know it's going to be, somewhere right here. It's 6, 5, yeah. It's going to be somewhere around here. But how can I get that for sure? So what you're doing is finding the average. You're finding the average of the x's, find the average of the y's. The average is the mean is the middle. So what's the middle of 1? Well, I'll use these. What's the middle of negative 6 and 5? What's the exact middle of those two? Alright, so I'll do negative 6 plus 5 divided by 2. That's the average. And we'll get a half. Negative 1/2. So I know this that. Negative 1/2 comma something. What's the middle of the 2 y coordinates? Negative 4 and 7. Again, just find the average. 7 plus negative 4 divided by 2, and we get 3 over 2, or 1.5. So actually, I estimated quite close. Pretty well. So same thing here. What's the middle of 1 and 4? 1 plus 4 over 2, which is 5/2. Please leave your answer as a fraction. Unless you're graphing, you might want to, change it to 2.5. But otherwise, that's okay. What's the middle of 2 and 6? 2 plus 6 over 2, 4. That's all. So we can find the middle just by finding the average of the x's, the average of the y's. The middle is the average. Do the same thing with fractions. 3/5 plus 1/4 divided by 2. Negative 7/4 minus 2/5. And of course, you can use your calculator to help you out as needed. Cancel, so we get 12, 17 over 20, 17 over 40. Okay, negative 43 over 40. Verify those. I did them kind of quick. Is that correct? Negative 39. 12 plus 5, 17. Is it right?
That's correct.
Okay. Thank you. So mentally, what am I doing? Okay. Adding the fractions. One way to add them is just do 12 plus 5, 17, all over 20. Then divide by 2, so 20 becomes 40. Because it's on the bottom. 17 over 40. Okay. Negative 35 minus 8, negative 43 over 20. Okay. Divided by 2 over 40. So again, have some number sense. I don't want you just blindly putting things in calculators and making 5th grade math difficult. You know, putting answers that make no sense. When you can do some mental math, mental arithmetic, and probably get the answer faster and more accurately. Okay, so one of those things we'll see, unfortunately, is that some people not finishing their tests or quizzes, and the whole time they're just busy punching everything in, and half of it might be wrong anyway. So try not to become attached to it too much. It's one of those things you have to kind of let happen and then learn the hard way for some people. Just hope it doesn't take too long. All right, that's about it. I'll let you guys get started.